Okay, let's do an example. This is from practice quiz 1, number 2. It says, suppose a tank initially holds 100 gallons of brine solution. That just means a salt-water mixture. That is 5% salt. Another brine solution that is 10% salt is pumped into the tank at a rate of 5 gallons per minute. So at the same time, brine is pumped out of the tank at 3 gallons a minute. Assuming the brine is always uniformly stirred, find dAdt, so where A is the amount of salt in the tank at time t. Okay, so let me draw a picture of this. Okay. Okay, so I've drawn the picture here. We have 5 gallons coming in. Here's my tank here. We got 5 gallons per minute coming in, and it's 10% salt. We have 3 gallons leaving at the bottom. And we know at time 0 it has 100 gallons, and it's 5% salt. Okay, so I guess there'll be 5 gallons of salt at time 0. So we have to find now the change in the amount of salt in the tank. Okay, so now let's look at salt in and salt out. Okay, so let's look at salt in first. Well, there's 5 gallons per minute coming in and 10% salt. So the amount of salt coming in per minute then would be 5 times 0.1. So it'd be 5 times 0.1. Okay, so it'd be 0.5. Let's find now salt out next. That's going to be a bit harder to find. Okay, actually before finding the salt out, let's find a formula for the volume. So it's initially at 100, but there's 5 coming in and there's 3 leaving. So in net there's 2 gallons coming in then. So therefore the volume would be 100 plus 5 minus 3 times t, where t here is measured in minutes. So it'd be 100 plus 2t. Okay, let's keep going. So let's find the salt out next. That's going to be harder because there's 3 gallons leaving, but the salt content is changing because there's 5 gallons coming in at 10% salt, and it's mixing with this here, and so it's changing the salt content. So it's not so obvious what the salt out would be. So let me write something here, then I'll explain it. So I've written this here, but let's come back to that in a second. But now at time 0 it had 5% salt, and then you have this 10% salt solution coming in. So you can see if you let this keep running, eventually it's going to go to roughly 10% in here, right? Because you have more and more 10% mixed with the 5%. So anyway, at any particular time it's going to be somewhere between 5 and 10% the salt in the solution, brine solution. So here's a formula I wrote here. Let me explain how I got this. So the top part is telling you how much salt is in the tank at time t. So there'll be salt in tank at time t. Then you're dividing it by the volume at time t. So this will give you then the salt divided by volume. So it'll be salt per gallon. Okay, then we're multiplying it by 3 because there's 3 gallons a minute. So let's give you the salt out then per minute right here. So again, this guy here in front gives you the salt per gallon. And we're multiplying it by 3 because there's 3 gallons per minute leaving. So this is kind of tricky to see, this part here. But again, you're taking the salt in the tank at time t, dividing by volume. So that'll be salt per gallon. multiplying it by gallons per minute. That would give you then the salt per minute leaving. Okay, so now we can write our formula for dA dt now. It's pretty much going to be salt in minus salt out. So let me write it here. Okay, so our dA dt, that's going to be the change in salt, will be salt in minus salt out. Okay, salt in is 0.5. And then salt out is this guy here. We can write it as 3A over 100 plus 2T. So like this, so it'll be 3A T divided by 100 plus 2T. So this is a differential equation. So this is a model our problem here. So we're done. Here's our equation for dA dt. Alright, so we're done.